All right, so today our discussion on transformations starts with what a transformation is. And transformation changes the position or size of a figure. Transformations can be applied to parent functions. So we're going to use the absolute value function as our guide, or as our basic function that we want to transform in these notes. All right, use the absolute value function as an example. So the parent function is f of x equals absolute value of x. That is our parent absolute value function. We could technically use any function that we want to do the example, but we're going to stick with absolute value because that's what we've been talking about. Now, when we graphed this yesterday, the day before, all right, we did a quiz yesterday, we learned how to use a table to graph an absolute value function. We said we're going to let the x, whatever's in the absolute value symbols, we're going to set that equal to 0. That's going to be the x value of our vertex. And then we subtract 1 to go up, and we add 1 to go down. And then we plug those values into the absolute value function. So this would be absolute value of negative 1, which is 1. Absolute value of 0, 0, 1. And then we graph those. Negative 1, 1, 0, 0, and 1, 1. And we have our graph. No big deal. All right, that is the parent absolute value function. Now, we are going to use our calculator to see what happens when we do certain things to this function. And you can see in these problems that we're doing different operations. We might add to the x. We might subtract from the x. We might add to the function or subtract from the function. We might multiply a number greater than 1 or a number that's between 0 and 1. Or we might have a negative out front. So we're going to see what happens in the calculator. So if you do not have a calculator now, I'm going to stop the video so you can get one. Alright, so we need to learn how to put a function into the calculator. The place that we go in the calculator to do this is y equals. So press y equals. Now you'll see your calculator may have some things plugged in for those. Let's clear that out. Just clear it out. And so there's nothing there. Alright. Now, next to y equals, we're dealing with absolute value function. So we're going to do alpha, window, enter, and that gives us our absolute value symbols. Alpha, window, enter. Now, we want to plug in x plus 2. The x button is right here below the mode button. So press x plus 2. Alright. Now, move your cursor outside the absolute value. Got it?
Yeah, I got you.
Alpha window. Enter. Yeah. Yep. Okay, now, we need to make sure that our scale is correct in our calculator. So press the window button. And where it says x min, it needs to be -5 instead of -10. X max needs to be +5 instead of 10. Y min needs to be -5. Y max needs to be 5. The scale, x scale and y scale both need to be 1, and that x res equals 1. Alright, so this is what your screen should look like. Once you have done that, what?
Where'd you say y min?
It's right there. Alright, so the next thing, we're going to press graph. And it should graph the absolute value function. You see that? If there's an error, then there was something that you plugged in a certain way wrong. Alright, window should be -5, 5, 1, -5, 5, 1, 1.
Oh my God.
That is amazing.
Alright, so remember you're on video. Alright, so we've got our function. Notice that compared to the parent function, I am shifted to the left 2 units. I want you to write that down. Left 2. left 2. Alright? Let's go to the next function. Press y equals again. Change it from x plus to x minus. And then press graph. Okay? So now look where the function is. It has been shifted to the right 2 units. So write that down. Right 2. Alright, let's do number 3. Yes, sir.
When you press window and go under X, res,
Mm-hmm.
there's a icon that's like a triangle and an X. What is that mean?
I have no idea. It's not something we needed to deal with.
Mine's in the, for number 3, it's in the...
Alright? What now?
It's in the for number 3.
Yeah. Yes. Alright, so let's do number 3. So let's do y equals. Now, we want to put this plus 2 outside the absolute value. So I'm going to delete the minus 2 and then go to outside the absolute value and do plus 2 and then graph. And there, yep, it is. Up 2. Write that down.
Down 2.
Alright. Hey, you got some insight. Okay, so now to do the next one, change it to a minus 2 instead of a plus 2. And it will be down 2. A little pattern going on here. Alright, I'll show you in a second. Alright, so look at number 5. If we go to y equals, we want to put a 2 in front of the absolute value of x. There's a quick way to do that. You do second delete, and that allows you to insert the 2. And then you delete the minus 2. So to put the 2 in front of the absolute value, make sure your cursor is at the very front of the absolute value. Do second delete 2, and it inserts the 2. Then press graph. Alright, now, notice that the vertex is the same as the parent, but it's more narrow. It has been vertically stretched by 2. So what we're going to say for this one is vertical stretch by 2. We took it and we basically stretched it, which made it more narrow, which basically you're changing the slope. You're making the slope steeper. Alright, so in number 6,
it's going to get wider.
It's going to get wider.
Where's delete?
Delete is next to mode. Right here. Okay? So we're going to change that to a 1/2. So to do that, you can do alpha y equals, enter, do 1/2, and then delete the 2 that was already there, and you have it. So press graph. So notice that the graph is still centered at the origin, however, it's wider. So we would call this a vertical shrink by 1/2. Okay, now we say a shrink. Another way we can describe a shrink is to compress. So we compressed and it made it wider. So write that down. Compressed, wider. For the vertical stretch by 2, it made it more narrow. Alright? The last transformation that we're going to look at here is number 7. So we go back to y equals. We're going to delete the 1/2. And we're going to insert a negative. Make sure you do a negative and not a minus. Negative and minus are two different things in this calculator.
It makes it wider on the bottom.
Yeah. It doesn't make it wider. It just reflects it.
Yeah.
It reflects it. So what we have here is a reflection over x-axis. A reflection over the x-axis. Now, in doing all of these transformations, the first 2 went together, the second 2 went together, the third 2 went together, and the last one stands alone. The first 2 are horizontal shifts. The next 2 are vertical shifts. The next two are vertical stretch / shrink. And obviously the last one is a reflection. And you don't have to describe it any other way. Now, over here on the right side of this page, we're going to look at, we're going to use this kind of as a guide for us. And what we're doing here is we're just looking at these transformations one piece at a time. Okay? Only one transformation at a time right now. So, it looks kind of like our wall of transformations. So, the first one, f of x plus h, if you look over at the wall, what type of shift is that? It is look at the wall, guys, look over there. It's a horizontal shift. And remember, if it's plus a number, it goes to the which direction? To the left. So this will be left. Alright, the next one is also a horizontal shift. Yep. And it is to the right. Okay, the next one.
It's going to be vertical.
Yep. Vertical shift. Up. And the next one, vertical shift down. Alright? Okay, the next type are the dilations. This is where we're dealing with a stretch or a shrink. A dilation is when we multiply the function by a number. Okay? If my number that I multiply by is greater than 1, in other words, if the number that's in front, if I take the absolute value of that thing, and it's greater than 1, it's going to be a stretch. We call it a vertical stretch. Okay, and if I multiply by a number that's less than 1, like 1/3, okay, it's going to be a vertical shrink. Okay? Now, the last one is the reflection. The reflection is going to, if the negative is in front of the function, it's going to be a reflection over the x-axis. Reflection over the x-axis, thank you. If there was a negative in front of just the x, it would be a reflection over the y-axis. But we're not going to do those. Okay, now, what I want us to do is turn over to homework 3. Homework 3. Now, I'm going to stop the video for just a second while we get there. Alright, so if we take a look at homework worksheet 3, the first questions are asking you about what the parent functions of these particular functions are. So easy. Alright, so if you look over there on the wall, what is the linear function, parent function? F of x equals what? X. Good. Alright, what is the parent absolute value function?
Absolute value of x.
There you go. Okay, now, we want to describe each transformation that they give us here. So in number 3, what is the -3 outside the absolute value telling us to do?
Absolute value function.
But what does it tell us to actually do?
Go right.
Shift down 3. And it's down 3 because this -3 is outside the absolute value. If it's inside the absolute value, it's left or right. Alright, Clay, what is this minus out front telling us to do? It's a negative, yes, but what does it tell us to do?
Go right.
What is it happening?
Go right.
No. It's a reflection. Very good. So we're going to say reflect. Alright, and then the +9 tells us to do what? Left 9. Who said that? Very good. So it's a reflect and a left 9. That's what's actually happening to the parent function. Compared to, listen, we always refer back to the parent. We're always comparing to the parent. So, compared to the parent, this particular graph has been reflected and shifted to the left 9. Alright, what about number 5?
Vertical stretch by 4.
Good. Vertical stretch by 4. And what else? Right 1. Very good. Okay, what about this next one? Reflect because of the negative. Now this fraction, it is a fraction, but is it greater than 1? Yes, it is. Alright, it's greater than 1 because 5 is greater than 3, right? So it's going to be, no, not shrink. If it's greater than 1, it's a stretch by 5/3. And we're going to see in just a minute, we're going to think of this number out front like it, as if it's a slope. Alright, so then the last thing here is to do what? Up to, because the 2 is outside the absolute value. Now, we're going to do some practice, and we're going to take a look at number 7 through 10 on the front, and then 13 through 16 on the back. And this is what you're going to do. This is so easy what we're about to do. All you're going to do, you are not going to graph anything right now. All you're going to do is tell me, or tell yourself, what the shifts and what the transformations are. So, just like what we just did. So, what is this?
Right 1.
It says right 1, and then the other -1 is what? Down 1. So, you're going to do that for each one of those, and then we're going to come back and check it. So, I'm going to pause the video and let you do that.